In our second episode, we talked about the multi-level technology in general and what possibilities we could bring to society with it. Back again, Manuel. In the first episode, we talked about the company BAVERTIS itself. Now we want to talk more about multi-level. So what is this technology behind BAVERTIS, so-called multi-level?
Now, the easiest way to explain is that a big battery, normally you have a big battery out of 8,200 cells in a Model S, for example. Small cells like 18650 cells. And they are all connected with plates, and there's no reconfigurable thing. So they are connected static for 400 volt, 800 volt. Well, the market is changing to 800 volt, and then there's an inverter, a motor, or a charging system which get the energy out of the grid into the batteries. And multi-level is changing the way of thinking about batteries. So you connect each cell or each parallel string of batteries with an inverter. So we have switches on 4 volt, not any longer on 800 volt side. And then it is possible to switch batteries on and off. So you can build your signal like with Lego bricks. So 1 battery on, 2 batteries on, 3 batteries on, building your sinus. And
so that means that each battery has its own, like, gets switched on and off individually, and not all are connected to one switch and get on and off.
Yeah, and the normal way is to switch them pretty fast, 70,000 times per second.
All of them
on and off. So 0 volt, 800 volt, 0 volt, 800 volt. And that's the way how power electronic guys think about. You will learn it in your second semester, and then it's a little bit strange because you want to build a sinus, and you switch it pretty fast. But if you have learned it, then it's logic, and you think just in 0 and 1.
Yeah.
It's in informatics the same thing, but multi-level is the future.
Yeah. And so multi-level, you're like having steps. So you're like going 4, 8, 12, 16 volts up until you have, and then like re-simulate the sinus.
Yeah, because of this, on the research side, the name reconfigurable battery is also used.
Mm-hmm.
Multi-level and reconfigurable battery, or AC battery, or software-defined battery. It's all the same thinking about batteries.
Yeah.
And that's completely different from the normal way.
Mm-hmm. So when you talked before about switching on and off, you meant pulse-wide modulation, DVM. Also, I think a lot of like hobby electronic guys already know it because you also use it for different kinds of like small motors, and when you like have your Arduino, you already kind of approach this technology. But it's crazy to think about that you like put 800 volts in it. But what are the differences now in the end when you like have a BVM approach or you have the multi-level approach?
The whole drive system is changing because you can integrate the charger, the inverter, the battery management system, and the battery management system is normally a passive one. So you have switches and resistors and burn the energy in the resistors. And I think it's not a sustainable way to use energy.
Mm-hmm. Yeah.
And there's also a proactive method to balance the batteries with multi-level, so you charge your batteries just in the way they need it. So this inclusion of 3 different parts is one of the big issues of multi-level converters. And if you think about multi-level converters more on the function side, it is possible to charge the batteries faster. So pulse charging is possible with multi-level converters, and you can charge your car 10% faster with the same losses. So on the research side, everything goes into the direction that pulse charging is the future.
Yeah.
But for a normal vehicle, you would need additional parts to do a pulse charging.
When you talk about pulse charging, how can we imagine that? Like normally you put your voltage on it and then it charges.
Yeah. It's normally how we learn it as an electrical engineer. We have to charge batteries with CV, so constant voltage, constant current approach, and first CC, then CV, and that's about a few minutes the same current, and then the voltage is constant. But if you charge it pulse width, you have to switch batteries on and off, like this Lego bricks, and with the frequency of 1.5 kilohertz, something like this.
Yes.
And at the beginning of my PhD, we thought that these pulses are disadvantage of multi-level converters, but then it became clearer and clearer that it is an advantage, and that's amazing. Because if you have if you think it's a disadvantage,
So the problem is a solution.
Look at back.
But so this like these findings that pulse modulation is better for batteries is quite new then.
Yeah, it's quite new, and the papers on the research side are increasing.
Yeah.
So just today I had found a new paper about it, and on the chair, at the university, we have bought a lot of climate chambers, cyclers, special cyclers, because a normal cycler cannot cycle the batteries with these high frequencies. And we want to do a big research project out of this, because there is no big study about it.
Yeah.
The tendency of the studies is, okay, it's good for the batteries, but the studies are mostly done with single cells or not with a constant temperature or something like this.
Very, very interesting to see also that you're like breaking new grounds in the scientific world also as a company. Yeah, quite inspiring. What are like the advantages and disadvantages of this?
So there are a lot of advantages. I think we will hear in the podcast more about all of the advantages, because you have to explain each advantage pretty long. About disadvantages, for the one side, you have not any longer this DC bus where you can connect your heaters or your climate. But it is possible if you think different of multi-level converters. I think we have to do a special episode just about how to do this. And it became for BAVERTIS also, I think, during the 1.5 year, it became clear how to manage this the advantage. And multi-level converters are better for motor for vehicles with one motor. So the tendency on the hypercar side is 4 motors, 1 for each wheel.
Yes.
On each wheel. And this is also not a strong point for multi-level converters. But it is also possible if you think
which, like you're saying that it's not possible to have 4 motors that are approached differently, or in general, if you have 4 motors, you only can have mechanically, like that you only have like 1 motor in the middle, and then this mechanically puts.
That's always possible.
Yeah.
The normal approach, if you think about combustion engine,
Yeah.
it's always possible. But having an electrical engine or a motor on each wheel, that's possible, but it's not the main.
Yeah, something I would find.
Because you are doing, you are building out of your batteries the silence directly, and if your battery is now the converter, there is no any longer this DC bus, and it's not that easy to have different frequencies on each wheel. And also, having a lower amount of batteries than 100 cells is not a use case for multi-level converters. So for small bicycles or something like this, it's not possible because you can then not use your multi-level converter as a charger, and then the overall system costs are.
Okay, yeah.
Also especially for automotive, it is necessary to be cheaper than.
Yeah, for sure. Perfect. But even if you're like talking later, or in the further episodes about the advantages itself more into detail, can you give us like a little overview about the main point?
For me, one of the big advantages is that you are if the system is shut down, though it's not driving with no charging, not charge it, we have just forward, though it's not any longer harmful. Think about a crash of a car. The fireman wants to get you out of the car, and with a normal electric vehicle, it is necessary to get the voltage shut down, and then he can rescue you. But with a multi-level converter, he can rescue you at the moment. He has seen you, and this faster charging, 10%, higher lifetime, 60%. For me, these are the main advantages. Then on the grid side, it is possible to have an bidirectional charging system, and higher lifetime with a bidirectional charging system for getting energy into your car and out of your car is a big issue, because each customer can earn 3,000 euros. I think we will also do a podcast episode about it. So 3,000 euros is a big thing. Wow, they have you as a student also. So I can do a holiday more or something like this. Or if you think about a lifetime of your car of 10 years, we have 30,000 euros.
But also if you think about how much like electronic cars cost, that you can also, like, when you can earn something out of it, it also like the cost of owning becomes way cheaper. Yeah. Very interesting.
No, there are cars outside which are not costing that much more than.
That's true. Yeah.
Yeah, and the rest needs a little bit more explanation.
Yeah, but I think you can still give us like an overview to have a full list of things you can.
Okay, so the THD is better, so you can increase the efficiency of the motor. It's not clear how big this impact is on the. If you think about 2 levels, though 0 and 800 volt, you can also think about 3 levels, 0, 400 volt and 800 volt. As change makes 1% efficiency on the motor side. Also this THD, this total harmonic distortion, is a measurement of how good the silence is. This on the grid a big issue. Normally you have grid filters, and you can get rid of it. Well, not any longer necessary. Here, Then on the battery side, if you think about switching batteries on and off, the switching on and off is a pretty good method to get information out of a battery. Though we have electrical impedance spectroscopy, which you can do with your batteries, and then you can estimate the state of charge better, how full is your battery, how good is the state of health, how old is the battery, and you're thinking. And you can also make a measurement or an expectation of the temperature. All this data science is a big issue, because if you have more information about your battery, you can send it into the cloud, make AI stuff or algorithms, learn about which load profile is good or bad for the batteries, and then change your load profile. And that's not possible right now.
Yeah.
I thought Tesla would do this in the future, but it's not possible.
Yeah, which is also like, I think currently a lot of cars suffer that sometimes the battery kind of drops, or the expectation also.
Estimation of the state of charge is not that easy. It's a big issue for sure.
Yeah, for sure. Then you're standing in the middle of nowhere.
Yeah, you know it from your mobile phone, though.
Yeah, when it still, that's true. When it gets older, also the estimation. Yeah,
the estimation is not that easy, but with prices, that's easier. Yeah,
to achieve. Very well. Do you want to add a feature, or?
I think I can talk a lot just about the features. I think one of the features which is interesting for customers is that second life is easy to do with such a system, because you have a software-defined battery, and it is possible to just changing the software. So, okay, battery, you are not any longer in a car, you are now running a home stationary energy storage system, and then
so second life of battery, like it gets batteries get out of the purpose they were used, and then put in a second device. Yeah. Okay. So when you're reading about multi-level, it's not a new technology. There has like this approach of putting different voltages over each other has been done for a long time. Do you want to talk a little bit or explain us a little bit about the history of the whole technology?
The beginning of the technology is 1963. There are the first patents. But thinking about modular multi-level converters, it began with Rainer Morford and Anton Lesliker, 2003, I think. And at the beginning, everyone on the research side have told them it's too many switches. The disadvantages are too high. It will never work because it's too complex and something like this. The same reasons we are hearing right now. And on the high voltage DC, high voltage direct current side, for 10,000, 100,000 volts, it's state of the art right now. So Siemens get it out of the research into a product for the first time, and then it became state of the art. But now a lot of researchers in China, because they're building this high transmission line.
And they're also like the biggest producers of batteries. I can imagine that's for some reason. Yeah.
Power electronics was once a big thing in Germany. We lost it in the Cupid.
Yeah. Like something to. Yeah.
But it's multi-level converters are working in a different field, but there is a module, a multi-level module, 2200 volt, something like this, and we're thinking about 4 volt.
Yeah.
It's a different approach, and this is possible because of the semiconductors which are out of Bitcoin farming, CPU, GPU clusters, which need a lot of energy on low voltage.
So this technology that BAVERTIS is currently developing has not been possible 5 or 10 years ago.
I would say 5 years ago it would be possible, and 10 years is maybe, but on the future though, a technical approach which is using active components instead of passive components, in the future would be always the best choice.
Yeah, like we see it also in past developments that there were always the switch between passive becoming to active approaches.
And I have thought in my lifetime many times, okay, this is the end of semiconductors, because also mostly on the power electronics side.
Yeah.
For the logic side that moves long and work for a while, I think that's okay. I could not completely understand how they do it, but on the power electronics side, it's amazing that we have this big improvement side now. So silicon carbide guiding nitride is out there.
Yeah.
And there's a long way to go until it is not any longer possible to have no better power electronics or something.
Mm-hmm. Interesting, yeah. What do you think about the future? How will the whole multi-level technology in general evolve?
I think we will do just multi-level on every time you have an DC source and different form of energy. So every time you have DC as the beginning, so for solar, for fuel cells, for electrolyzer, and for batteries, on each topic it makes totally sense to them, multi-level converters. And on the application side, it's always above 100 batteries or solar cells or something like this. But for cars, motorcycles, ships, the full range of mobility and stationary system.
100 battery means 400 volt approximately.
We need 360 volt peak on the silence side. That's at 230 volt times square root 2 times 10% performant.
Okay. So I would say we come to an end of our second episode. Do you want to add something?
Okay. No, perfect.
Famous last word.
Famous last words. I have no.
Then we are
parasite motivation. My man.
If that let it like that. So thank you, and you will see you in the next one.